Greetings, this is Anthony Dick. This is finishing off difference quotients. I wanted to show you one where you have to evaluate the difference quotients for a square root. Now, when you have to do this, you have to go through a process of rationalizing the numerator. But to recall, the difference quotient is f of x plus h minus f of x all over h. Now, again, you don't have to memorize that. That will be given to you. You're not expected to just remember that's the difference quotient. But you will be expected to use it. Now for this, that means f of x plus h, put x plus h in there. So it's going to be the square root of x plus h minus 4. So I just took x plus h and put it in for x. And this is going to be subtracting f of x. Well, f of x is right there, square root of x minus 4. And this is all over h. Now, with polynomials and rationals and linear things, we've been able to combine like terms and simplify things and cancel, but we're not going to be able to do that with roots. With roots, what you have to do is you have to get rid of these roots, and you do that by rationalizing the numerator. And the first step in there is to multiply the whole numerator and the denominator by the conjugate pair of these roots. So these roots are being subtracted, so I'm going to add them. So x plus h minus 4 plus the square root of x minus 4. Now, if I do it on the top of the fraction, I have to do it on the bottom. So it's multiplying it by 1 in reality, because the square roots of stuff over the square roots of stuff all over itself. This whole thing is equal to 1, so I'm not changing this. Now, here's what's going to happen. Let's take a look at this piece by piece. When I'm multiplying this first root times that first root, well, that's just going to make x plus h minus 4. Okay? This root times that root, a negative times a positive, makes a negative. And the square root of x minus 4 times the square root of x minus 4 just makes x minus 4. Now I have to be careful because that negative right there, the plus, minus plus, applies to the whole thing. Now, in distributing this thing through, remember you're multiplying that whole numerator times that whole numerator here. So I've got to multiply the middle terms. So check out what happens. I end up with negative this root times that root. Well, that makes negative square root of x minus 4 times x plus h minus 4. Remember, when I multiply a root times a root, I can actually combine them underneath the same root. But then I have to multiply this times that over there. So the square root of x plus h minus 4 times a positive square root of x minus 4 makes a positive square root of x plus h minus 4 times x minus 4. So the inside here times the inside here. These cancel. They will always cancel. That's the whole point of multiplying by its conjugate pair. So this is just the numerator. Okay? So when you multiply that radical times its conjugate pair there, what you're left with is x plus h minus 4 minus x minus 4. If you just want to make yourself a note in your mind that, hey, whenever I multiply a pair of radicals that are subtracted times a pair of radicals that are added, the same things, I just have to multiply this times this and it erases the radical. This times this and it erases that radical. Subtract them, and these middle terms are always going to cancel. Now this whole thing is over h times this whole deal, the square root of x plus h minus 4 plus the square root of x minus 4. Now, if you're being bothered right now because you're saying, wait, Dick, I thought we couldn't have roots on the denominator. Well, we don't really like them there, but our bigger object, remember, when we're doing difference quotients, is we've got to cancel that h right there. That's going to be happening somewhere. This is the way we get there. Because check out what happens here on the top. If I simplify this, x plus h minus 4, that's just there, x plus h minus 4 minus the x minus a negative 4 makes a positive 4, and that's all over this h times the square root of x plus h minus 4 plus the square root of x minus 4. Check out what happens. X minus x, that's gone. Negative 4 plus 4 is gone. And you've got a negative h. That's all that's left in the numerator. So negative h all over h times the square root of x plus h minus 4 plus the square root of x minus 4. H cancels h, and I have a negative on the top. Well, the negative's got to have a number, so negative 1. That's holding the top. And on the bottom, I've just got this. Square root of x plus h minus 4 plus the square root of x minus 4. And that's it. As soon as you're able to cancel that h, you know you're done. Okay, I don't need to worry about these radicals on the bottom. They're fine. The object is to cancel the h. So in summary, difference quotients for roots. We start off setting it up. And then you always multiply the numerator times its conjugate pair. So these same two radicals, if they're added, you subtract. If they're subtracting, you add. You do it top and bottom. When you distribute it out, the first root's going to cancel, and the second root's going to cancel, and you're going to be subtracting the insides. These middle terms will always cancel each other out. That's what will happen. Then you're going to be ending up something like this. And in here, you're going to be able to cancel everything out there except for things that have an h. That's all that's going to be left. And then you will always be able to factor an h or cancel an h top and bottom, and you're left with something like that, where there's no more h's in the denominator. That's the goal, okay? And that's the last thing that we're looking at for this particular unit. Okay, a lot of stuff. See you next time.